Alright, today we are going to continue on in our quadratics unit, where today we are going to learn how to find the rate of change of quadratics and their graphs. If we remember anything about rate of change, another word for rate of change could be slope. And our slope formula is, remember the letter we use for slope is m, and the slope formula is y2 minus y1 over x2 minus x1. So if I'm going to need two y's and two x's, that means I need 2 points, which I was given here in the problem. I have my first x, my first y, my second x, and my second y. So now I'm going to plug into the formula. y2 is -4 minus y1, which is 1. Then x2 is 4 minus x1, which is -6. And let me type this into the calculator. I'm going to make a fraction and just do it all directly. -4 minus 1, and then at the bottom I'm going to have 4 minus -6. And when I do that, I get -0.5, or you could leave it as a fraction, -1 over 2. Most of the time you'll see slope as a fraction and rate of change as a decimal, but it doesn't matter which way you represent it. Just remember that if we're using slope to graph a line, we would want it to be a fraction. That way we would know the rise over the run. So today we are going to learn how do we calculate the rate of change of quadratic equations and of their graphs. Alright, what is rate of change? The rate of change function is defined as the rate at which one quantity is changing with respect to another quantity. This is very similar to slope, where we are trying to find how much does y change in respect to how much does x change. We can use the slope formula and the rate of change interchangeably and use the same formula. So we're just trying to find how much does the y values change over how much does the x values change. Alright, so rate of change of a quadratics. The slope of a straight line, remember, another word for straight line is linear, measures a rate of change where at one point it is the same along the line. That is because if you look at this, if you take the rate of change from here to here, it's going to be the same as from here to here. These rises and these runs are going to be the same. Since the line is increasing or decreasing at the same rate, we say that the rate of change is constant, which means it's not changing. The rate of change of quadratic functions, however, is not constant. It does not remain the same. Let's think about it. If I look at a quadratic right here, I can't say that it's the same because from here to here we're decreasing, where from here to here we are increasing. So the rate of change would not be constant. So, can we speak of slope with parabolas? The answer is yes, in a way. But the result won't be the same as what we have seen with straight lines. When we try to speak of the slope or rate of change for a quadratic function, which is a parabola, we have to speak of the average rate of change, the slope of a segment containing 2 points of the parabola. We can't say that it's the slope of the whole entire equation. It's just the slope of 2 certain points. The difference would be that the average rate of change, or the slope, will not be constant. It will change based upon the location of the 2 points being used. Alright, so let's look at rate of change along this parabola. Consider this parabola. This is the one y equals x squared, and we're trying to find the average rate of change. Alright, in this first part here, they found it from 0 to 1. And when they did that, they found that they rised 1, ran 1, so the slope or average rate of change is 1. But now if you look at it from point 1 to point 2, you actually rise 3 and run 1, making the average rate of change 3 over 1, which is just 3. And then if we try to find the slope from 2 to 3, we rised 5 and then ran 1, making the slope 5. So if you see, as x increases by 1, the slope starts to increase too. So that is why when we find the average rate of a parabola, we need to be told what points they want us to find it from. Because if they don't tell us, we're going to get different answers. Alright. Where did we go? Alright. So now, individual practice. Let's find the average rate of change where x is 3 and x is 5. So we're going to look for 3. 1, 2, 3 is right here. This is my point right here for 3. And let's look for 5. 5 would be right here. All right, let's see our rise over our run. We rose 1, 2, 3, 4, but we went down, so our rise would be -4. And then we ran 1, 2, 2. Let me just count again. 1, 2, 3, 4, 1, 2. All right, and let's type this in the calculator. -4 over 2, that would equal -2. So our average rate of change is -2. All right, let's look at it again. Guided practice. Sally went on a bike trip and stopped regularly at half-hour intervals. At each break, she recorded her total distance since leaving home. What was Sally's average speed during the first half hour? First half hour means from 0 to 0.5. So that was my time. That's what should go at the bottom, because time is technically x and distance is y. So I'm trying to find out from 0 to 0.5. Well, let's think about it. At 0, she must have been 0 away from home because she was still home. But then at 0.5, she was 7 away from home. So let's type this fraction into the calculator. 0 minus 7 over 0 minus 0.5. And that gives us an average speed of 14. And let's see during the last half hour. All right, during the last half hour with these points right here. All right, so this is my x2 would be 3, my x1 would be 2.5, and then 3 goes along with 36, and 2.5 goes along with 28. All right, let's type this in the calculator. 36 minus 28 over 3 minus 2.5, and we get 16. So she started getting faster during her trip. All right, let's look at this one. The graph below shows the distance in miles hiked from a camp in each hours. Which hourly interval had the greatest rate of change? All right, let's look from 0 to 1. Well, she rose. That's technically 1. That's 2. 2 over, and that's 1 hour, which means that it was 2. All right, let's look at this next one. From hour 1 to hour 2, she rose from 2 to 2.5. So 2 to 3.5 would be she rose 1.5. And how much did she go over? She went over 1 hour. So that would be 1.5. So that wouldn't be my answer. I'm looking for the greatest rate of change. Let's look at this next one. From hour 2 to hour 3. All right, she went from 3.5 to 4.5, which means she went up 1, and then she went over 1 hour. So that would be just 1 over 1. And this last one, from hour 3 to hour 4. She only went up 0.5, and then she went over the hour. So it would be 0.5 over 1, which is just 0.5. So our answer would be choice 1. That is our greatest rate of change. All right, let's look at this next problem. All right, so hopefully you guys tried this problem. This problem says, firing a piece of pottery in a kiln takes place at different temperatures for different amounts of times. The graph below shows the temperature in a kiln while firing a piece of pottery after the kiln is preheated to 200 degrees. During which time interval did the temperature in the kiln show the greatest average rate of change? All right, so from 0 to 1. All right, from 0 to 1. Well, that's the time only changed by 1 hour, but we started at 200 and we ended at 700, which means our temperature changed 500 degrees, so that would be a rate of change of 500. Let's look at this next one. We started at 1 hour and we ended at 1.5 hours, which means that we changed 0.5 hours, and the temperature started at 900 and ended at 700, meaning it changed 200. And now what is 200 divided by 0.5? That would be 400, average rate of change of 400, which would not be my answer because I'm looking for the average rate of change. All right, let's look at the next one. From 2.5 to 5 hours, that would be a 2.5 hour difference. And at 2.5, we start the temperature at 1,300. And then at 5 hours, we end at 1,600. 340. So let's subtract those two temperatures, and we get 340. And let's do 340 divided by 2.5, and we get 136. So that also would not be my answer. And let's check from hour 5 to hour 8. Well, that would be a 3-hour difference. We started at our temperature at 1,800, and then it ended 1,640, which is 160 divided by 3 is 53 point something. So that would not be the answer. So it is choice 1. From 0 to 1, that was the biggest jump in our temperature. All right, let's look at this one. A manager wanted to analyze the online shoe sales for his business. He collected data for the number of pairs of shoes sold each hour over a 14-hour time period. He created a graph to model the data as shown below. Okay? The manager believed the set of integers would be the most appropriate domain for this model. Why is he incorrect? Integers means negative and positive numbers. Now let's think about it. Can time ever be negative? No. Time never negative. All right. Then it says, state the entire interval for which the number of pairs of shoes is increasing. Well, we're increasing from right here up until right here. So we start increasing at hour 0, and we stop increasing at hour 6. So we would say from 0 hour to 6 hour. All right, determine the average rate of change between the 6th and 14th hour. All right, so this is the 6th hour right here, which is the 0.6, 120. And then 14 is right here, which is at 14.0. So it would be 120 minus 0 over 6 minus 14. And let's type that in the calculator. 120 minus 0 over 6 minus 14 means we decreased at negative 15. So this means every hour sales went down 15. All right, let's look at this next one. Given the functions blah blah blah, the correct list of functions ordered from greatest to least by average rate of change over the interval 0 to 3 is. All right, let's look at this first one. If I want to find the average rate of change from 0 to 3 right here, right? I'm trying to find it from 0 to 3. So I need to find what would my value be when I put 0 in this equation. If I put 0 in this equation, what would I get? I would get 0. Okay? And if I put 3 in this equation, what would I get? Let's see, 3 squared minus 2 times 3, I get 3. And now let's type this fraction in the calculator. 0 minus 3 over 0 minus 3. I get 1. So that means for g of x, I get 1. All right. Now let's look for f of x. They want to know from 0 to 3. Okay? So this is my x1, x2, y1, y2. So I would have 7 minus 1 over 3 minus 0. Well, let's do that in our calculator. 7 minus 1 over 3 minus 0 is 2. So f of x, the rate of change is 2. And let's look lastly here. From 0 to 3 is right here. All right, so I rose 1, 2, 3, 4, 5, 6. And I ran 1, 2, 3. So that would mean 6 over 3, and we would get 2. We shouldn't be getting the same thing, so let me see. Where did I make a mistake? From 0 to 3, you definitely, and then you went up 1, 2, 3, 4, 5, 6. 7 minus 1 over 3 minus 0 is 2. Alright, well we know h of x or f of x is going to have to come first. And we know that g of x is going to have to be last. So our answer would have to be choice 4. Yeah. Alright. Let's look at this one. An astronaut drops a rock off the edge of a cliff. The distance is modeled by this, and they want to know from 5 to 10 seconds. So this is our x1 and our x2, but now we need a y1 and a y2. In order to figure that out, we are going to plug in 5 to the equation, and then we are going to also plug in 10 into the equation. And we would get 20 and 80. And let's use this to set up our slope formula. 80 minus 20 over 10 minus 5. And that gives us 12. Very nice. Alright, that concludes our lesson on finding the rate of change, average rate of change of quadratics and their graphs.